Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we're going to do the opposite of what we did in a previous lesson. See, previously you were given an equation. You turned it into a table of values or a graph or both. This time we're doing the opposite. You're going to be given a graph or a table of values and you're going to find the equation that represents it. So it's actually pretty easy. The equation of any line can be written as y equals mx plus b. We've been introduced to m before in a previous lesson. M is the gradient, the rise over run. How much y values are changing each time the x value increases by 1. M is just the gradient we've already learned about. B is the y-intercept. I'll show you what that means, but it's just where the graph hits the y-axis. So because any line can be written in this form, all we need to do is find m and find b. So let's look at some examples. We'll start with a table of values. So here we have 3 tables of values. For each of them, we will find the equation that links x and y. Let's start with this one here. So all I need to do to calculate the equation that I require, I need to find m and find b. We know how to find m. We did that in a previous lesson. M is the gradient. It's the number by which y increases each time x goes up by 1. So you can see that y is going up by 1 each time x is going up by 1. So that means that the gradient here is 1. So now what we need to do is find the y-intercept. So what is that? Well, let's say I were to plot this graph. It would be a straight line. So the y-intercept is where it hits this axis here, the y-axis. So along here, the x-coordinate is 0. It would hit the y-axis up at 9. So if it was 9, the line would look like this. The y-intercept of this line is 9. A way you can think about the y-intercept, it's the y value when x equals 0. So that tells us that it will hit the y-axis at 9. That means b, which stands for the y-intercept, is 9. So the equation that links x and y here is just y equals m times x plus b. What does this equation mean? Well, it means if I graph this equation, it will go through all of these points. Another way to think about it, this is the rule linking x and y. This tells you how you get the y value in this table if you know the x value. It's saying to get the y value, you just take the x value and add 9. So minus 2 plus 9 is 7. Minus 1 plus 9 is 8. 0 plus 9 is 9, and so on. It's a rule telling you how to get the y value if you know the x value. So let's look at this table over here. Calculate the gradient and the y-intercept. So for the gradient, we know each time x is going up by 1, y is actually going down by 2. So the gradient is negative 2. What is the y-intercept? It's the y value when x equals 0. So it's minus 11. So the equation of this line is just y equals mx plus b, minus 2x minus 11. Once again, this is a rule that tells us how to get the y value if we know the x value. It says times the x value by minus 2, then subtract 11, and you get the y value. So minus 2 times minus 2 is 4, minus 11 is minus 7. This point here works too. If you go minus 2 times 2, then subtract 11, you get this value here. All right, let's look at this one here. So this is a bit tricky because once again, x is not going up by 1 each time. It's actually going up by 2. But we learned how to deal with this situation in the lesson on the gradient. So each time x goes up by 2, y goes down by 6. So the gradient here is minus 6 over 2, which is minus 3. This is saying each time x goes up by 1, y would go down by 3. And that makes sense. If I put x is minus 2 in here, the y value would be 6. If I put x is 0 in here, the y value would be 0. And so on. If I put 2 in here, I would get the y value minus 6. So that's what happened if I did the table completely. Each time x goes up by 1, y goes down by 3. So if x goes up by 2, y goes down by 6. So gradient's minus 3. So the y-intercept, well, it wasn't listed on the table here, so what I had to do was add it in. So if I know that each time x goes up by 1, y goes down by 3, I knew that this number would be 0 because x went up by 1, y went down by 3. The y-intercept is 0. I can just add it into the table if it's not there. So that means the equation of this line will just be y equals minus 3x plus 0. I don't need to write the plus 0 though. So this is saying that each y value is just negative 3 times the x value. Minus 3 times negative 3 gives 9. 3 times negative 3 gives minus 9. 5 times negative 3 gives minus 15, and so on. All right, let's look at finding the equation of a line now when we're given the graph. So let's say I'm given this graph here and I want to find its equation. All I need to do is find m, find b. So m is the gradient. Remember, it's the rise over the run. So I've gone across 3 and up 6. The gradient is going to be rise, how much I've gone up, divided by run, how far I've gone across. The gradient is 2. The y-intercept, as I said, is just where it hits the y-axis. It hits at 6. So the y-intercept's 6. The equation of this line is y equals mx plus b, y equals 2x plus 6. So let's say we're given this line here and we want to find its equation. Same thing, we need to calculate the gradient and calculate the y-intercept. But I'm going to show you a different way. See, some people like the tables. What we can do is we can take all the points that are plotted here and put them into a table. So the table would look like this. I got this table just from putting in the x values and the y values. So like minus 1, 8 is this point here, 0, 5 is this point here. So once we put it in a table, we can do exactly like we did on the previous slide. So here, each time x is going up by 1, y is going down by 3. So in this case, the gradient is minus 3. The y-intercept is the y value when x is 0. It's where the line hits the y-axis. It's 5. So the equation of this line is y equals mx plus b, minus 3x plus 5. So when you're given the graph, you can do either way. You can put the points in a table like I did here, or you can just calculate the gradient using rise and run and look at the y-intercept. Either way is fine. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.